Here you can see the CH2 molecule, and in this diagram you can see the symmetrical stretching of CH2 molecule, the asymmetrical stretching, then in plane bending, out of plane bending, or you can say twisting or wagging, and in plane bending or rocking. And you can also see that under these diagrams you can see that frequencies are also written, that these stretching, for example, if you look at the first diagram, the symmetric stretching of CH2 will be observed at 2853 per centimeters, and similarly asymmetric stretching will be observed at 2926. In plane bending or sistering is observed at 1465. So you'll see that here there is a difference in frequencies of all the bands, whether they are symmetrical stretching or any kind of bending. We have already discussed in our last video about Hooke's law. Here you can see what the equation looks like, where the mu naught is vibrational frequency in per centimeters, c is the velocity of light in centimeters per second, f is force constant of the bond in dynes per centimeter, and mx and my represents the mass of the atoms x and y in grams respectively. The value of F is approximately 5 into 10 raised to power 5 dynes per centimeter for single bond, and it is approximately doubled and taken as twice for double and triple bonds. And the force constant is usually taken as the stiffness of the bond, and it is correlated with such properties like bond order and bond strength. Because the frequency is directly related to the square root of the force constant, we know that frequency of bond vibrations should either decrease as bonds decrease in strength. The frequency of the bond vibrations that we measure in basically in IR spectroscopy should decrease as bonds decrease in strength. As the bond gets weakened, the frequency of that particular bond should decrease. Now we have observed certain absorption regions using Hooke's law, and we have compared the absorption regions of certain bonds with the observed values. We have calculated them with the Hooke's law and then the observed and compared the both. Now if you look at the CO bond, the observed value ranges from 800 to 1300, whereas the calculated value here is 1113, that is 1113, which lies in the range. Now if we look at carbon, single bond carbon, then the observed values are approximately the same, that is 800 to 1300, and the calculated value here using Hooke's law was 1128, which also falls in that particular range. Now carbon, single bond nitrogen, the observed values as mentioned on the whiteboard are 1000 to 1250, and the calculated value is 1135, which lies in the observed range. Now if we look at carbon, double bond carbon, it also the range, observed range is 1500 to 1900, and the calculated value using Hooke's law was 1657. Similarly, if you look at carbon, triple bond carbon, that is written here, the range is, observed range is 2100 to 2150, and the calculated value is 21,001, which also falls in this observed range. Carbon, single bond hydrogen, the observed value is from 2850 to 3000, and the calculated was 3032. Similarly for OH, the range is 2700 to 3800, and the calculated value is 3553, which is very much close and lies in the range. Thank you very much for your time.